one more you can try at home. You take the blades. These are the shaving blades, what we have will be using in home and barber shops. So keep two blades. There's a blade, upper blade, and there's a lower blade. Let there be a narrow gap between them. A small gap is there. You eliminate these two blades. You eliminate this gap by a laser beam, red color beam of laser beam of light. What do you expect the pattern? The pattern on the wall. So what you do is better go in the pitch dark room. Take cardboard, something fixed like this. So let this be a gap, and the small narrow gap you produce between these two blades. Then you illuminate, let the laser beam focus exactly at this particular gap. Then make observation of the pattern on the wall. So you expect a bright central band, then minima, maxima, minima, maxima. Okay, now what do we expect? Like a ray of light. So practically what we expect only the bright band, no? Only this gap is illuminated, so only this gap should come. Why this particular light? Due to bending of ray of light. So this is central maxima. Why do these things are coming? Why these things are coming? This is due to diffraction, bending of ray of light. The ray of light which encounters here, it encounters sharp edge, it starts bending. It starts bending in all direction. And because of that here, maxima, minima, interference will occur, maxima, minima will get hit. So then I'll increase the gap. On paper, I'm showing it, central maxima. So why do these strips? Why do this region? Due to diffraction. Due to diffraction. Only rectilinear propagation means only central maxima is what I should get. Due to diffraction, due to wave nature is what I'm getting, secondary maxima and minima. Pattern on screen or wall, diagram on paper. We think like this. Practically, it will be like this. Pattern formed on wall when you illuminate the blades with a red color laser beam. What is the cost? In India, it will cost you around 50 rupees. Enough. And the blades, shaving blade, 5 rupees. Within 60 rupees, you really are going to learn this diffraction phenomenon to some extent. So the gap between the blades will act like a rectangular slit. This gap will act like a rectangular slit. So the ray of light passing through this will undergo diffraction. So due to diffraction is what we get this maximum minimas. Now I'll increase the gap between the blades. Then what I notice is like, I'll get next only one spot. So these patterns, what's happened? Pattern which was there, no, these things will disappear. If the gap between the blades, if I increase to certain width, for certain width, these things what happen will disappear. We get only the one dark one, the bright band. The red colored band is what you notice. Again, you decrease the width of the gap. Then this pattern again, the secondary maxima will be visible. So therefore, the width of the gap here will determine the presence of this maxima minima. These maxima minimas. This will be present all the time, central maxima. So the gap between the blades, what will happen? Here will determine pattern. Will it be this kind, what is shown in the first diagram or the second diagram? So when do we get only one bright band? When the width between the when the width of the gap increases to certain value, then we get only the bright band. These secondary maximas, what we call, no, they will disappear. So why do this? Due to diffraction. That's all, finished. The simplified one. Okay, let's do one thing. So what is our syllabus? So we'll start with this one. So let the there's a slit, rectangle slit. I'll illuminate with a ray of light. Let lambda be the wavelength of the light and let d be the width of the slit. Okay, the light after diffraction. So what we know, what we expect in the practically, we just do expect only this part of the region will get illuminated because only light is present here. Why do light has reached here? How come the light has reached? Due to diffraction, due to bending of ray of light. So the light which comes here will undergo the diffraction, bending of ray of light. So because of that, now a superposition of the waves due to different path difference will take place. We get maximas and minimas. So the pattern on the screen will not be like this. This is the pattern. We'll get a bright band. Next immediately is the first dark band, first bright band, second dark band, second bright band, first dark band, like this. The pattern will be symmetric. These are called as secondary maxima minima. This is called as central maxima. Now, what is all we should, and what is this, sir, what diffraction it is? Fresnel or Fraunhofer? This is an example of Fraunhofer diffraction. I'm not showing that lens. I'm not showing that lens. So if you want to keep the lens here and keep one lens here and keep point source. The Fraunhofer diffraction we are discussing. So complete dark central maxima, complete dark D1, D2, D3, D4, we'll get it. Now we should try to, we'll put an effort to explain why the intensity here is maxima, why the width of this is more than this. In case of interference, all the bright bands are having same width, but you look at the central maxima. It is having more width than the first bright band. Try to see this. Are you noticing any difference? This width and this width. This width is definitely more than this one. So we have to give suitable expression why the width of this one is more. And we have to also give a suitable expression for where do the dark and bright bands will be located and why the intensity of this is more compared to this one. In interference, we get all of same intensity. All maximas will have same intensity. Here, the central maxima will have more intensity. And as you move away from central maxima, the intensity of bright bands keeps on decreases. Are you noticing one more thing? And what is the width of all bright bands will be same. The width of second bright band and the first bright band will be same. So we'll put an effort to understand what actually this concept and how, why the pattern is like this is what we have to give a mathematical treatment for this. I think, okay, this is okay, we'll do one thing. We'll end up the class till here. Okay, the next class will happen. I'll continue with the discussion on this, particularly okay, why only intensity here is having maxima, why the width of central maxima is more than the width of secondary maximas, and how to get the angular width of the different maximas, their angular position, the linear position, then resolving for all those things.